Hello there, and welcome to Forgotten Worlds. My name is Thomas, and tonight I'd like to take you on a journey into the deepest corridors of time. Settle in, let your breath slow, and picture the Earth not as it is now, but as it has been. 4.5 billion years old, restless, scarred, and always remaking itself. For a brief span, just 165 million years, the dinosaurs ruled this world. Their bones fill our museums, their shadows haunt our imaginations. But what came before them? What lived? What dreamed? In the vast reaches of time that stretch back beyond their reign. Science tells us with confidence that no advanced civilization existed before us. That complex intelligence, cities, languages, technologies, is a story only humans have written. Yet, in the quiet space between fact and possibility, another question lingers. What if that's not the whole truth? What if long before the first dinosaur thundered across the land, another civilization had already risen, perhaps thriving in ways we can scarcely imagine, only to vanish so completely that time itself forgot them? Their traces erased by oceans, by mountains, by the patient grinding of plate tectonics. Not a debate, but an exploration. A slow wondering. Could there have been sparks of intelligence in ages so remote that even the rocks struggle to remember them? Tonight, we'll let that question breathe. We'll drift back into the Paleozoic seas, across forgotten forests, through cataclysms and extinctions, and ask what might have been. But before we imagine those ancient builders, we have to step into the vastness of deep time itself. Imagine holding a clock in your hand, not the kind that ticks away hours and minutes, but one that measures billions of years. On such a clock, humanity's story would appear as the faintest scratch on the glass, so thin it might vanish if you looked at it from the wrong angle. Dinosaurs, those titans we so often picture as the deep past, would occupy only a single hour or two, and everything before them, oceans forming, continents drifting, forests rising and falling, would fill almost the entire dial. This is deep time, a scale so vast that our usual ways of thinking struggle to hold it. We count birthdays, dynasties, even civilizations, but deep time counts in plate movements, in mountain ranges that take millions of years to rise and fall, in species that flourish for tens of millions of years before vanishing forever. It is a story told not in books or bones, but in stone, and even then, the stone itself is an unreliable narrator. If you look back beyond the age of dinosaurs, you encounter eras so long they make our own history feel almost weightless. The Paleozoic alone, the span just before the great Mesozoic age of reptiles, stretched for nearly 300 million years. Think about that. That's more than 60 times longer than the entire age of mammals since the dinosaurs went extinct. And yet, when we imagine Earth's past, most of us skip straight from primordial soup to dinosaurs. The hundreds of millions of years in between often fade into silence. But silence is not the same as emptiness. In that silence, whole ecosystems rose and vanished. Seas surged over continents and then receded. Forests grew so dense they altered the atmosphere itself. Trilobites crawled across seabeds for nearly 270 million years longer than dinosaurs ever managed before disappearing completely. Amphibians experimented with living on land. Insects, once tiny and fragile, grew into giants with wingspans wider than hawks. The planet itself was alive with movement and possibility. When you stretch your imagination across this scale, something extraordinary becomes clear. There was more than enough time not just for life to appear, but for life to try and fail, again and again. Enough time for intelligence to flicker like a match, struck in the dark bright for a moment, then extinguished, leaving no smoke, no ash, only the faintest chemical memory trapped in stone. Mainstream science holds, quite reasonably, that no evidence exists of civilizations before us. Yet even scientists have begun to ask a provocative question. If one had existed, would we even know? NASA researchers once framed this as the Silurian hypothesis, a thought experiment designed not to prove ancient civilizations, but to highlight just how poorly geology preserves signs of them. Their conclusion was sobering. The deeper you go in time, the harder it becomes to find anything at all. Rock is recycled, mountains erode, ocean floors are swallowed. Even our own civilization, with its skyscrapers and satellites, might vanish almost without a trace if given just 10 million years. Now stretch that erasure back not 10 million years, but hundreds. Picture an entire world of builders, thinkers, storytellers, whoever they might have been, erased so thoroughly that only the barest whispers remain, disguised as natural anomalies, a sudden spike in carbon, an odd layer of minerals, a puzzling extinction curve. To us, they read as geology. To them, they may have been history. This is the vertigo of deep time. You gaze down into it and realize how fragile our presence is. You begin to see Earth not as a single continuous story, but as a palimpsest, a manuscript scraped clean and written over, again and again. Each civilization, if any existed, would be like ink too faint to survive the next rewrite. And yet the possibility lingers, because in hundreds of millions of years, chance allows for many experiments. Perhaps somewhere in that span, in the long Devonian swamps, in the shadow of the great Carboniferous forests, or in the winding estuaries of the Permian, intelligence flared briefly. Not human, not mammal, not even familiar. Something stranger. Something adapted to worlds we can hardly picture now. They might not have left pyramids or stone circles. They may never have carved their names into rock. Their traces might lie instead in forgotten isotopes, in chemical oddities no one has yet thought to question. And so we return to the central tension of our exploration. When we look at deep time, we are staring at an ocean far wider than human history, an ocean whose waves may have carried more than one civilization into existence, only to pull them back into the dark. As we continue, keep this image close. Earth as a restless storyteller, always erasing its drafts, always beginning again. If civilizations bloomed before the dinosaurs, they bloomed in this silence, vast, unrecorded, but not impossible. And that brings us to the next step. If time itself erases, how could we ever hope to know? To answer that, we must turn to a curious question asked by modern scientists. Could geology reveal traces of ancient civilizations, even if they lived hundreds of millions of years ago? This is the heart of the Silurian hypothesis, and it will guide us deeper still. In 2018, two NASA scientists, Gavin Schmidt and Adam Frank, posed a question that sounded more like science fiction than science. They called it the Silurian hypothesis, named after a group of reptilian beings from British television, but their aim was serious. They asked, if an industrial civilization had existed on Earth millions of years before us, would we be able to tell? At first glance, the answer seems obvious. Surely a civilization leaves traces, buildings, machines, fossils of their bodies. But then you remember the vast machinery of Earth itself. You remember that the oldest ocean floor is only about 200 million years old, younger than the first dinosaurs, because the planet continually recycles its crust. You remember that mountains rise and crumble, rivers carve valleys, glaciers grind the surface smooth, volcanoes spread new stone across the land. Time, in geological terms, is not passive. It is an eraser. Imagine, for a moment, leaving your house untouched for 1,000 years. Wood decays, glass shatters, metal rusts, vines pull the walls apart. Now stretch that process out for 1,000,000 years. Not only is the house gone, but the soil has shifted, rivers have changed course, and perhaps an entire ice sheet has passed over the land. In 10 million years, your house might lie buried under a mountain range. In 100 million years, the stone it rests in might be pulled into the Earth's mantle and melted. This is the backdrop against which Schmidt and Frank asked their unsettling question. If we disappeared tomorrow, what traces of us would survive millions of years hence? The answer is sobering. Almost nothing. A few curious anomalies, perhaps, embedded in stone. The Silurian hypothesis suggests that if another civilization had once existed, whether 10 million years ago or hundreds of millions, the evidence we would expect might not be physical artifacts at all, not skyscrapers or bones or roads, but geochemical fingerprints. These might appear as unusual isotopic ratios, a sudden spike in carbon, for instance, suggesting the burning of fossil fuels, or deposits of synthetic materials, such as plastics or certain alloys, which do not occur naturally, or even subtle shifts in sediment layers, hinting at mass agriculture or industrial activity. Yet even these traces would be fragile. Erosion and tectonics would erase most, scattering them until they became indistinguishable from the background noise of geology. And here is where the thought experiment becomes dizzying. If traces of our own civilization might fade almost entirely within 10 million years, what chance would there be of detecting a civilization that lived before the dinosaurs hundreds of millions of years ago? The odds collapse to nearly zero. Take a breath and imagine this. Somewhere in the vast Paleozoic swamps, an intelligence rises. It learns, it builds, perhaps it even alters its environment. Then, through catastrophe or slow decline, it disappears. 300 million years later, all that remains is a thin chemical line in stone, so subtle that modern geologists might pass over it without a second glance. We would see it not as evidence of cities or machines, but as an unusual carbon excursion, the kind of anomaly attributed to volcanic eruptions or climate shifts. Civilization hidden in plain sight, disguised as geology. This is why Schmidt and Frank stressed humility. When we dig into Earth's layers, we are not reading a neat archive but fragments, whispers, half-erased words on a page written long before us. We may be missing entire chapters. Now, apply the Silurian hypothesis backwards, to times before the dinosaurs, to the Silurian itself, 400 million years ago, when the first forests grew, to the Devonian, when fish experimented with legs, to the Carboniferous, when dragonflies with wings wider than dinner plates filled the skies. Each of these ages lasted tens of millions of years. Each provided a stage vast enough for intelligence to arise, and if it did, it could vanish without leaving a trace strong enough for us to recognize. Think about the fossil record. Even for ordinary life, it is astonishingly incomplete. Most creatures that ever lived left no trace at all. Fossilization requires a near miracle: rapid burial, protection from decay, mineral replacement, and then the survival of that rock for millions of years without being destroyed or buried too deeply to find. The chances of an individual organism becoming a fossil are vanishingly small, and the chances of a tool, a building, or a piece of technology surviving, smaller still. This does not mean civilizations existed. It means that, if they did, the Earth would be almost perfect at hiding them. Our search, then, cannot rely on looking for the obvious. It must be subtler, searching for anomalies that look like geology but might carry another explanation. Consider the thin, dark bands of coal found in Carboniferous rock. To us, they are the compressed remains of vast forests, buried and transformed into carbon. But what if, among those natural processes, there were traces of deliberate burning or widespread land use? Consider the sudden spikes of greenhouse gases in ancient sediment. We attribute them to volcanism, but could some have another origin? It is here, in these blurred edges, that the Silurian hypothesis invites us to wonder, not to claim, not to insist, but to let curiosity linger in possibility. Perhaps the anomalies are natural. Most likely, they are. But perhaps, hidden in plain sight, is a forgotten story. And as you let that thought drift, notice how it shifts our perspective. We begin to see ourselves differently. Our civilization feels less permanent, less inevitable. We are not the pinnacle of history, but perhaps one experiment among many, fragile and brief, as likely to vanish as anything that came before. So as we move deeper into our journey, let's hold on to this. The Earth is a master of erasure. It does not keep diaries. It recycles its surface, scrubs away its past, and leaves only hints. If a civilization rose before the dinosaurs, its traces would be almost invisible. Not because it lacked significance, but because time itself is a patient destroyer. And that brings us to the stage upon which this mystery might have played out. The pre-dinosaur Earth itself. A planet lush with seas, forests, and strange creatures, a world both alien and familiar, waiting to be imagined. Picture the Earth between 541 and 252 million years ago. Long before dinosaurs thundered across the land, the world was already alive with abundance. This was the Paleozoic era, a span of nearly 300 million years, a time so vast that human history, from the first cave paintings to the International Space Station, would fit inside it thousands of times over. If you could stand there, at the shoreline of a Paleozoic sea, the view would feel both wondrous and unsettling. The oceans stretched wide, but they were not quite the oceans we know. Their chemistry was different, their colors shifting with the minerals dissolved within. Along the seafloor, strange corals built reefs that towered like underwater forests. Trilobites scuttled across the sediment, their armored bodies glinting in filtered light. Above them swam early fish, jawless and alien, experimenting with shapes that would echo down through evolution. In the shallows, life pushed boundaries. Plants crept onto land for the first time, small and tentative at first, but gradually rising into dense forests. Imagine ferns taller than houses, their fronds unfolding in humid air. Imagine dragonflies with wings wider than a hawk's, hovering in the heavy atmosphere, where oxygen levels soared higher than today. Amphibians clambered from water to land, their footprints pressed into soft mud that hardened into stone traces we still find today. The air itself was alive in ways unfamiliar to us. During the Carboniferous period, around 300 million years ago, oxygen levels reached nearly 35% compared to today's 21%. Fires raged more easily, insects grew to enormous sizes, and animals breathed in a richness that fueled experiments in form and function. It was an Earth in the midst of innovation, trying out countless designs for survival. Could such a world have supported intelligence beyond instinct and survival? That is the question we linger on tonight. Mainstream science reminds us that intelligence, as we know it, requires not just brains, but opportunity, stable climates, abundant energy sources, ecological niches where creativity could flourish. And the Paleozoic offered all of these, in cycles that lasted millions of years at a time. Imagine a lineage of cephalopods, ancient relatives of squid and octopuses already present in those seas. Even then, they were hunters with complex nervous systems, capable of rapid camouflage and problem-solving. Their modern descendants demonstrate remarkable intelligence, able to open jars, recognize patterns, and navigate mazes. If today's octopuses can do this with only a few million years of evolution behind them, what might their Paleozoic ancestors have achieved in the long expanses of deep time? Perhaps they were simply predators, clever but limited. Or perhaps, in ways we cannot yet grasp, they reached further. On land, synapsids, the distant ancestors of mammals, roamed forests and river valleys. Some grew large, with teeth designed not only for tearing but for chewing, a step toward more complex diets and behaviors. Their bodies hint at metabolisms more advanced than their reptilian neighbors. If intelligence is linked to adaptability, to experimentation with energy and behavior, then these early synapsids may have held the seeds of something greater. But the environment itself mattered too. The Paleozoic was not a single static world. It was a restless stage where continents collided and broke apart. Oceans expanded and vanished. Climates swung between extremes. Supercontinents such as Gondwana and later Pangaea gathered land into vast interiors, where climates turned harsh and isolating. Deserts stretched across what are now lush forests. Ice ages came and went. These constant upheavals forced life to adapt quickly or perish. And in adaptation, opportunities for intelligence may have emerged. Think of the forests of the Carboniferous. Vast, humid, and interconnected, they created stable, resource-rich environments that lasted tens of millions of years. Within them, creatures could have developed not only survival strategies but complex behaviors. Picture amphibians gathering near ancient rivers, responding to seasonal floods with rituals we cannot imagine. Picture cephalopods in shallow seas building temporary shelters of stone and shell. These images may be fanciful, but they remind us that intelligence is not bound to our form. It may have worn many shapes before us. Yet if such experiments in intelligence occurred, they were vulnerable. The Earth of the Paleozoic was generous but unforgiving. Mass extinctions punctuated its story, wiping away vast portions of life in sudden intervals. The late Devonian extinction, for example, erased 75% of species, reshaping ecosystems completely. The final act of the Paleozoic, the Permian-Triassic extinction, was even more catastrophic, annihilating 90% of life in what scientists call the Great Dying. If any civilization had taken root before then, its erasure would have been absolute. And yet, the possibility lingers in the silence. When we walk through Paleozoic stone today, we see fossils of trilobites, plants and amphibians. We see coal seams, layered thick with the remains of ancient forests. But what we do not see, what we cannot see, are the stories that might have been. If intelligence bloomed briefly in those eras, its traces may lie hidden, disguised as ordinary geology, waiting for a question bold enough to reveal them. So as we step further into this ancient earth, let yourself imagine standing in one of those primeval forests, the air thick with oxygen, the sky alive with giant insects, the ground echoing with the calls of amphibians and early reptiles. Somewhere in that richness, perhaps, a spark of thought flickered, a mind not human, not mammal, but aware, a mind that looked out across the forest or the sea and wondered, in its own way, about its place in the world. Could this environment have supported complex intelligence? The answer is not certain, but it could have. And in the immensity of deep time, could may be all we need to let the question breathe. As the Paleozoic moved toward its final chapters, life on Earth was not fading into quiet simplicity. It was bursting outward in complexity. The Permian period, beginning around 299 million years ago, saw ecosystems grow into intricate webs that stretched across land and sea. Forests of conifers and seed ferns spread over the supercontinent of Pangaea. Rivers wound through valleys where amphibians, reptiles, and the first true ancestors of mammals carved out their niches. In the oceans, corals built reefs that rivaled those of today, while ammonites and brachiopods flourished in dazzling variety. It was a time of expansion, what some call the Permian explosion. Predators and prey grew more specialized. Herbivores adapted to graze new kinds of plants. Carnivores developed sharper teeth and stronger limbs. Synapsids, those mammal-like reptiles, were diversifying into dozens of forms, some small and furtive, others massive and dominating the landscape. Dimetrodon, with its towering sail of bone and skin, was not a dinosaur, but a predator that ruled long before them. Around it lived creatures whose lineages would echo into the future, ancestors of mammals, reptiles, and perhaps even birds. This was not just an age of survival, it was an age of experiment. Earth, in its restless creativity, seemed to be rehearsing possibilities. Each ecosystem built upon the last, weaving more intricate connections, finding new ways for energy to flow from sun to leaf to animal. If intelligence arises where complexity thrives, then the Permian world offered fertile ground. Imagine an early lineage of synapsids whose nervous systems grew more sophisticated, whose behaviors stretched beyond instinct. Imagine cephalopods in the seas, already clever hunters, refining their problem-solving in ways we can barely guess. In the deep stretches of time, millions of years provide enough room for remarkable possibilities. And yet, the Permian was not only a story of growth, it was also a stage being prepared for catastrophe. Around 252 million years ago, at the very end of the era, Earth experienced what scientists call the Great Dying, the most devastating extinction event in the planet's history. Nearly 90% of marine species vanished. On land, about 70% of vertebrate families were wiped away. Whole forests collapsed. Coral reefs dissolved. Life itself seemed to teeter on the edge of total erasure. What caused such devastation? The evidence points to massive volcanic activity in what is now Siberia. The eruptions, known as the Siberian Traps, released unimaginable volumes of lava, carbon dioxide, and methane. The atmosphere thickened with greenhouse gases, oceans warmed, oxygen levels plummeted, and vast stretches of water turned toxic with hydrogen sulfide. On land, climates swung between extremes, and ecosystems unraveled. For hundreds of thousands of years, the planet was in chaos. Now pause and imagine this from the perspective of intelligence. If any had taken root, a civilization, perhaps emerging in the late Permian, might have looked upon a world rich with resources, abundant with life. It might have thrived for tens of thousands of years, even millions long enough to tell stories, to build structures, to shape its environment. And then, without warning, the earth shifted. The skies darkened with ash, temperatures soared, seas turned poisonous. The foundation of survival crumbled beneath their feet. In such a scenario, no ingenuity would suffice. No technology could withstand oceans stripped of oxygen or air turned into poison. Even the strongest species were brought low. Trilobites, which had endured for nearly 270 million years, disappeared forever. Coral reefs, once widespread, collapsed completely. The slate was wiped clean. If a civilization had existed, it would have been erased in the same sweep, not just defeated, but forgotten, its traces folded into the chaos of stone and sea. This is where the mind lingers on the fragility of permanence. We often think of civilization as something solid, something that builds upon itself, generation after generation. But in the lens of deep time, civilization is fragile. It is a spark, and sparks are easily extinguished. Consider the coal seams of the Permian, formed from the remains of forests that stretched across Pangaea. Today, we burn them as fuel, releasing their stored sunlight back into the air. But what if, buried among those layers, there are subtle anomalies, chemical patterns hinting at deliberate burning, or traces of compounds shaped not by accident but by choice? To us, they appear as ordinary geology. But could they conceal the last whispers of something more? The thought is unsettling, and it is meant to be. The Permian extinction was thorough. It did not just kill species, it reset the Earth itself. Ecosystems had to begin again from near zero, slowly rebuilding over millions of years. The stage that would eventually host the dinosaurs was made possible by this cleansing fire. But what else did it erase? We cannot know for certain. Perhaps there was nothing but forests, reptiles, and seas filled with ammonites. Perhaps intelligence had not yet stirred, but the scale of time, the depth of possibility, makes another answer linger. Perhaps there was something, a civilization unfamiliar to us, living in the strange landscapes of the Permian, extinguished so completely that only the rocks remember. And so, the Permian reminds us of two truths. First, that life is capable of dazzling diversity, weaving complex webs of interaction that seem to edge ever closer to awareness. And second, that the Earth itself does not hesitate to sweep the board clean, to reset its experiments with a single cataclysm. As we drift from this chapter, hold on to that tension. A world full of possibility, erased in a moment. A civilization, if it ever existed, swallowed by fire and sea. And in its absence, a new stage prepared, a stage that would soon be claimed by the dinosaurs. When we think of intelligence, our thoughts often default to ourselves. Language, cities, technology, the intricate weaving of memory and imagination. But if we step back, far back, and let the Paleozoic Earth spread out before us, other candidates appear. Strange, ancient lineages that flourished long before the dinosaurs, each carrying within them hints of complexity, problem-solving, and awareness. Trilobites were among the earliest contenders. For nearly 270 million years, these armored arthropods scuttled across seafloors, burrowed into sand, and crawled through reefs. They were not passive creatures. Fossil evidence shows sophisticated compound eyes, some of the most advanced optical systems of their time, capable of detecting motion and light with precision. They adapted to countless environments, evolving into thousands of species. Some burrowed, some hunted, some filtered food from the water. The diversity of their strategies hints at behavioral flexibility, the kind of trait that, given enough time, could have been a foundation for greater intelligence. Imagine trilobite colonies in shallow seas, cooperating in ways now erased, their stories folded into stone. Then there were the cephalopods, squid, octopus, and cuttlefish ancestors who swam through Paleozoic waters. Even in those early ages, they displayed remarkable nervous systems, capable of rapid color changes, agile movement, and cunning predation. Modern cephalopods are celebrated for their intelligence, solving puzzles, remembering solutions, showing curiosity about tools. If their ancient relatives carried even the seeds of that ability, then they were already pioneers of cognition hundreds of millions of years before us. Could a cephalopod civilization have risen in coral reefs or shallow seas, crafting tools from shell and stone, building knowledge in patterns we cannot decode? Perhaps, and if it did, the oceans themselves would have erased their works. Saltwater devours artifacts, bones dissolve, shells crumble. What survives is only a whisper in the fossil record. On land, early amphibians ventured from water to forest. Their footprints, preserved in ancient mud, remind us of their courage in crossing boundaries. These were not simple fish, but creatures experimenting with lungs, limbs, and new ways of living. Some were small and fragile. Others grew massive, with heavy jaws and armored skulls. Though their brains were modest, the very act of conquering land was a triumph of adaptation. With every step, they rewrote the possibilities of life. And where adaptability thrives, intelligence sometimes follows. One can imagine amphibians gathering at the edges of swamps, developing rudimentary communication, perhaps even communal strategies for survival. Their legacy is not intelligence as we know it, but the courage to explore a trait that underlies every civilization. And then there were the synapsids, often called the mammal-like reptiles. They were perhaps the closest analogues to us in that ancient time. Some were small, scurrying insect-eaters with sharp teeth and quick reflexes. Others grew into large predators with sails or heavy bodies. Their skulls show openings for strong jaw muscles, but also hints of expanding brain cases. They were warm-blooded, or at least on the path toward it, suggesting higher metabolisms and more active lifestyles. If any lineage in the Permian had the potential to step toward true intelligence, the synapsids may have been it. Imagine a branch of them evolving not into mammals, but into something parallel, beings with awareness, curiosity, and the beginnings of culture. If they existed, they were lost in the great Permian extinction, erased so thoroughly that only their bones remain, scattered in deserts and stone. What evidence do we have of problem-solving in these lineages? Fossils alone cannot tell us much about behavior, but they offer clues. The complexity of trilobite eyes suggests an advanced interaction with their environment. The hunting strategies of early cephalopods hint at cunning and adaptability. Amphibians, in their transition from water to land, displayed the kind of bold experimentation that intelligence often demands. Synapsids, with their varied forms and metabolic innovations, were carving new paths through ecosystems. But it paints a picture of potential of lineages that might, given enough time, have reached for more. Speculation asks us to imagine what such civilizations would look like. A trilobite society might have been built on movement and coordination across reefs, their compound eyes mapping the shifting light of shallow seas. A cephalopod culture could have thrived in the language of color and gesture, sharing knowledge in displays that shimmered across the water. Amphibian gatherings may have relied on sound, the first calls echoing across swampy forests, half communication, half ritual. Synapsid groups, perhaps, could have organized hunts, shared resources, and passed on knowledge in ways invisible to the fossil record. Would any of these have built tools? Perhaps not in the way we think of them. Intelligence does not require hammers and fire. It may express itself in symbiosis, in architecture grown rather than carved, in behaviors we cannot recognize as technology. What matters is the spark, the reaching beyond instinct toward choice, memory, and meaning. The tragedy of deep time is that we cannot know. The fossil record is biased toward the durable. Shells, bones, teeth. It does not preserve thought. It does not record rituals, cooperation, or culture. Civilization, if it bloomed before the dinosaurs, may have left only the faintest of geological fingerprints, buried among the noise of volcanism, climate swings, and extinction. And yet, letting yourself wonder about these candidates is part of the exploration. Trilobites with their jeweled eyes, cephalopods with their restless minds, amphibians venturing onto land, synapsids testing the boundaries of metabolism, each represents an experiment in complexity. Each represents a path that could, under the right circumstances, have led to intelligence. As you drift with this thought, notice how it shifts your sense of time. Humanity feels less like an inevitability and more like a coincidence, one branch among countless others that might have reached for the stars. In another timeline, perhaps the oceans birthed civilizations of cephalopods who sang in color. Perhaps the swamps nurtured amphibian philosophers who gazed at the moon from fern-shrouded riversides. Perhaps synapsids told stories beneath alien constellations long before mammals were even imagined. These are not certainties, they are possibilities, and in the silence of deep time, possibility is all we have. Among all the candidates for ancient intelligence, one lineage stands out with particular strangeness: the cephalopods. Even today, octopuses, squid, and cuttlefish remind us that intelligence is not the exclusive domain of mammals or birds. It is something that can arise in soft, fluid bodies, with no bones at all, with lives measured in short years rather than centuries. Modern octopuses display a catalogue of abilities that seem, in some ways, uncomfortably familiar. They solve puzzles, sometimes after only one attempt. They remember solutions across days and weeks. They learn by watching. They can recognize individual humans, responding differently to those who treat them kindly and those who do not. They are escape artists, slipping through impossibly small openings, opening jars, and even manipulating aquarium valves to flood floors or short-circuit lights. And then there is their camouflage. Within seconds, an octopus can shift its color, texture, and shape to match its surroundings. It is not simply reflex, it is a decision, informed by vision and context. Some species even use this ability for communication, flashing signals of warning, aggression, or invitation. In their bodies, language takes the form of light and skin. Now pause and let this thought sink in. The common octopus has been evolving along its own path for more than 300 million years. Its ancestors swam in the same seas as trilobites and ammonites. They survived multiple mass extinctions, including the Permian catastrophe that erased nearly everything else. They are survivors, and survivors often carry hidden depths. The fossil record tells us that cephalopods are ancient indeed. Straight-shelled nautiloid forms dominated the seas of the Ordovician 450 million years ago, growing to lengths of several meters. Coiled ammonites thrived throughout the Paleozoic and Mesozoic, their shells leaving beautiful spirals in stone. And hidden within that lineage were the soft-bodied ancestors of modern octopuses, creatures with brains large for their body size, eyes eerily similar to ours, and a nervous system spread not just in the head but throughout their arms. Each limb could taste, touch, and even make decisions independently. This is where the paradox arises. If intelligence is about adaptability, problem-solving, and awareness, then octopuses have it in abundance. Yet they live such short lives, often only a few years. They do not pass knowledge down through generations in the way that mammals or birds can. They do not raise their young. Instead, mothers die after laying eggs, leaving their offspring to fend for themselves. Intelligence blooms, but it does not endure. And so we are left with the paradox. Here is a lineage with all the ingredients of intelligence, stretching back hundreds of millions of years. And yet it never built a civilization as we would recognize it. Or did it? Speculation invites us to imagine. What if, in the deep reaches of the Paleozoic or Permian, some branch of cephalopods broke the mold? What if they found ways to extend lifespan, to teach their young, to accumulate knowledge across generations? A civilization of cephalopods might not have carved stone or forged metal. Their world was water, and their tools may have been ephemeral. Arrangements of shells, patterns of color, labyrinths woven in coral. To us, such works would be invisible, dissolved long ago. But to them, it could have been culture. Consider their language. Today, octopuses communicate through gestures, postures, and flashes of color. Imagine this scaled upward into complexity. A living language of light that shimmered through reefs and across open seas. Entire histories might have been told in the patterns of skin, agreements sealed with a ripple of iridescence, warnings broadcast in sudden stripes. If such a language once flourished, it would leave no fossil, no inscription, only the faint memory of possibility. And what of architecture? Cephalopuses today build dens from rocks and shells, arranging their surroundings with deliberation. Some carry coconut shells across the seafloor, using them as portable shelters, a kind of tool use that rivals early primates. Extrapolate that back into deep time. Could their ancestors have built more elaborate refuges, structures woven from coral, kelp, and stone? Structures that, once abandoned, would dissolve into the sea, indistinguishable from natural reefs. It is tempting to dismiss these visions as fantasy, and yet the paradox remains. Why should intelligence arise so powerfully in cephalopods and persist for hundreds of millions of years without ever reaching for more? Perhaps the answer is that they never needed civilization. Their environment rewarded flexibility, not permanence. Their brilliance lay in survival, not in monuments. Or perhaps, just perhaps, they did reach for something greater, but the ocean, with its relentless erosion and decay, erased every trace. If that were true, then the story of Earth might hold a hidden chapter, a civilization of cephalopods, thriving long before the dinosaurs, wiped clean by time and sea. We cannot prove it. We cannot disprove it. What we have is the paradox itself, lingering like a question mark in deep time. And so, when you watch an octopus shift its colors in a tide pool, or see the spiral of an ammonite fossil in stone, let yourself wonder. Are you looking at a survivor of countless extinctions, carrying only the memory of what might have been? Are you seeing not just an animal, but a ghost of a forgotten intelligence? The octopus reminds us that intelligence is not inevitable, not linear, not confined to our form. It is fragile, fleeting, and strange. It may arise, flare brightly, and vanish without ever leaving a record we can read. That is the paradox. That is the mystery. When we speak of civilizations, we often imagine monuments, pyramids rising against desert skies, temples carved into cliffs, highways and bridges, towers and domes. But deep time does not care for such things. Stone endures, but only in certain forms. Wood rots, metal rusts, plastics crumble, and even concrete crumbles to dust under the patient touch of erosion. After a few thousand years, the bones of a city begin to vanish. After 1,000,000, the land forgets it entirely. After hundreds of millions, not even memory remains. The fossil record gives us a sobering reminder of just how little survives. When you see a trilobite fossil, perfectly preserved in rock, you are not looking at a common outcome, but an extraordinary accident. Fossilization requires rapid burial, mineral-rich waters, and just the right conditions to replace flesh and shell with stone. Out of the countless trillions of creatures that have lived, only a fraction have ever been fossilized, and only a fraction of those are ever uncovered. What this means is simple and daunting. Even life itself, abundant and diverse, struggles to leave traces across 300 million years. How much less, then, would the tools of civilization endure? Imagine a machine left in the open air. Within years, rust eats its surface. Within centuries, it collapses into fragments. Within millennia, even those fragments are buried, broken, and scattered. By the time millions of years have passed, its atoms have been folded back into the crust of the earth. A city fares no better. Skyscrapers, highways, ports, all would crumble, drowned by floods, buried by sediments, pulled apart by shifting ground. Plate tectonics would take care of the rest. Whole continents have risen and sunk in the time since the Paleozoic. Oceans have opened and closed. Mountains taller than Everest have risen and worn away to plains. Against such forces, even the mightiest of human works would be erased. And yet, traces do survive. A ripple pattern in ancient sandstone, the imprint of a fern leaf, the delicate outline of an insect's wing. These are the rare survivors, fossils that made it through the gauntlet of time. If structures or artifacts ever existed before the dinosaurs, they would need to endure this same gauntlet. A carved stone might last longer than wood, but over millions of years, even it would weather into dust. A fragment of pottery or metal might persist for a time, but eventually it would corrode, dissolve, or be swallowed by the earth. This is why archaeologists of deep time do not expect to find buildings or tools. Instead, they look for indirect markers, unusual chemical signatures, isotopic ratios that hint at industry, anomalies in sediment that cannot be explained by natural processes. Civilization would not survive as ruins in the desert. It would survive, if at all, as whispers in the rock, subtle patterns almost indistinguishable from nature itself. Consider, too, how rare it is for entire environments to be preserved. The famous Burgess Shale in Canada, which captures exquisite details of Cambrian creatures, represents one of only a handful of sites worldwide where conditions aligned perfectly. Without those conditions, we would have no record of those strange early animals at all. Multiply that rarity across hundreds of millions of years, and you begin to see why the silence of stone does not necessarily mean absence. It may simply mean loss. Think of the coal seams laid down in the Carboniferous. To us, they are the compressed remains of forests that lived 300 million years ago, now transformed into carbon-rich rock. But within those layers, what else might have been buried? The trees tell their story because their chemistry allowed it. Other stories, softer or stranger, may have vanished entirely. It is humbling, then, to realize how fragile memory is on a planetary scale. Civilizations, if they arose before the dinosaurs, would not stand as ruins for us to find. They would be erased, folded back into stone, surviving only as anomalies so faint we might not recognize them even if we looked directly at them. And yet, there is a strange comfort in this thought. The Earth remembers, but in its own way, not in monuments, but in layers. Not in names, but in patterns of carbon, in isotopes of oxygen, in the rare alignment of fossils pressed into stone. To read these is to read whispers, to hear faint echoes of lives that once were. So, when we ask why no cities, tools, or machines survive from 300 million years ago, the answer is not simply that they did not exist. The answer is that even if they had, deep time would have swept them away. The Earth is a patient recycler. It writes over its own pages again and again, and in that endless rewriting, almost everything is lost. But not everything. Some marks remain, if only faintly, and it is toward those faint geological signatures, the possible fingerprints of intelligence, that our curiosity now turns. If you were an archaeologist of today, you would sift through soil for pottery shards, bones, and buried walls. But if you were an archaeologist of deep time, searching not for traces of Rome or Babylon, but for something that might have existed 300 million years ago, your tools would look very different. You would not be looking for statues or temples. You would be looking for chemistry. Civilization, after all, leaves more than stone. It leaves fingerprints in the very fabric of the planet. Plastics, metals, isotopes, these are the quiet residue of our presence. Even if every city crumbled and every building vanished, the Earth would still carry our mark in its rocks and sediments. The question is, could similar marks exist from long before us? Plastics are one example. They are synthetic polymers, unknown in nature until humans created them. Billions of tons of plastic now circulate through oceans and landfills, breaking down into microfragments that sink into sediments and even become embedded in rock. Millions of years from now, geologists may find plastiglomerate stones fused with melted plastic as enduring markers of our age. If another civilization had once created something similar, would we notice? Or would we dismiss it as an oddity? A curious mineral with no story attached. Metals, too, leave traces. Our minds carve scars into the earth, stripping away layers in search of copper, iron, and rare elements. Our smelting releases isotopic signatures into the air. Future geologists may detect unusual concentrations of metals in strata, not easily explained by natural processes. If such anomalies appear in ancient rock layers, spikes of nickel, sudden enrichments of rare earth elements, could they be the fingerprints of industry from a forgotten age? Or are they the result of volcanism, asteroid strikes, or other natural events? And then there are isotopes, atoms with unusual ratios, created by nuclear reactions or specific industrial processes. Our use of fossil fuels already leaves distinct carbon isotope signatures in the atmosphere and oceans. Future geologists Millions of years from now, we'll see this as a sharp line in the sediment record, the Anthropocene marker. If civilizations before us burned fossil fuels, their legacy might look similar, a sudden carbon spike buried in the stone. Yet we already know of such spikes moments in Earth's history when carbon levels surged. We call them by geological names: the Paleocene-Eocene thermal maximum, the Permian extinction. Most are attributed to volcanism or methane release. But could one or two be something else? Civilization mistaken for catastrophe. This is the dilemma of the archaeology of deep time. Natural processes mimic artificial ones, and artificial signatures dissolve into natural explanations. A spike in carbon may mean volcanoes. A mineral anomaly may mean asteroid impact. A strange layer in the rock may mean climate shift. Without context, without artifacts, the fingerprints of intelligence blur into the fingerprints of Earth itself. And yet, anomalies do exist. Thin bands of rock where carbon ratios shift dramatically. Odd deposits of minerals in places that defy easy explanation. Patterns in extinction and recovery that seem, at times, abrupt. Most likely, these are natural, but in the spirit of wonder, we can allow another possibility to sit beside them, that one or two might be the shadows of something forgotten. Imagine a civilization that never built with stone, but altered its world chemically. Perhaps it extracted metals, leaving unusual concentrations in ancient soils. Perhaps it burned fuels, altering isotopes in a way that still lingers faintly in strata. Perhaps it produced synthetic materials that, while long degraded, left ghostly residues bound within sediments. To us, they are indistinguishable from volcanic byproducts. To them, they were the record of their existence. This is the haunting challenge, distinguishing nature from artifice, when nature itself is capable of producing nearly everything we attribute to civilization. Fires rage without cities. Methane pours into the air without industry. Oceans acidify without factories. Earth has written these chapters many times, with or without us. So how do we tell? The answer, for now, is that we cannot. The archaeology of deep time is as much philosophy as science. It forces us to confront how fragile intelligence is in the geological record, how thin our presence might appear millions of years hence. It teaches us humility, reminding us that certainty dissolves the deeper we look. And yet, perhaps this humility is the point. The marks of ancient civilizations, if they ever existed, would be faint, indistinguishable from Earth's own handwriting. To find them, we would need not only sharper tools, but a willingness to accept ambiguity, to let possibility linger alongside probability. So as you listen tonight, imagine yourself not as a traveler in the present, but as a geologist millions of years in the future. You sift through stone and find a curious spike of carbon, a band of minerals, a trace of something unusual. Do you call it volcano? Do you call it asteroid? Or do you whisper, quietly, civilization? When science grows quiet, myths often step forward to fill the silence. Long before geology and paleontology traced Earth's story through stone, people were already asking questions about the world's past. Where did we come from? How long has the Earth been here? Were there ages before our own? Across cultures, across centuries, the answers arrived not as measurements or isotopes, but as stories. The Hindu tradition speaks of the yugas, vast cycles of time in which worlds are created, flourish, and decay. The Satya Yuga, an age of truth, gives way eventually to the Kali Yuga, an age of decline. When one cycle ends, another begins. It is not a straight line of history, but a wheel that turns again and again. Listen closely, and you hear an echo of deep time itself. Civilizations rising, falling, and rising again, so long that memory becomes myth. In Mesoamerica, the Aztec tradition tells of the 5 suns, 5 worlds that came before, each destroyed in its own catastrophe. One was swallowed by jaguars, another swept away by wind, another by fire, another drowned by flood. Our present world, the fifth sun, is said to be temporary too, destined one day to end. Beneath the poetry of these myths lies a familiar rhythm: creation, destruction, renewal. Life begins, life flourishes, life vanishes, and the cycle repeats. The Greeks told of the ages of man. First came the Golden Age, a time of ease and harmony. Then the Silver Age, when people grew restless. Then the Bronze Age, when violence flourished. Then the Age of Heroes, when legends walked the earth. And finally, the Iron Age, the present heavy with toil and sorrow. Though not measured in millions of years, these ages still point to a truth we recognize: that civilizations rise and decline, and that we are perhaps not the first to imagine we stand at the pinnacle. What makes these myths haunting is their universality. Separated by oceans and centuries, cultures across the world imagined that the earth was older than their own time, that it had seen worlds before theirs, that they were not the first. Myths of floods, fires, cycles, and ages recur again and again. Did ancient peoples intuit the rhythms of geology without science? Or were they remembering something, however faint, passed down as story long after fact was lost? It is tempting to wonder whether myths might hold a kind of fossil record of memory, not of trilobites or ammonites, but of human imagination trying to grapple with time's immensity. Myths are not literal history, but they are not meaningless either. They encode patterns, intuitions, deep resonances. A flood myth, for example, might echo memories of real ancient floods, amplified into cosmic stories. A cycle of worlds might reflect the observation that civilizations fall, cities crumble, empires dissolve. And perhaps, at the farthest edges, they might hint at something deeper still: the possibility that the Earth has indeed seen ages of intelligence before, erased so completely that only story remained. Imagine a civilization erased by the Permian extinction. Imagine that, somehow, a fragment of memory survived not in stone, but in whispers, carried forward across countless generations of life, until it reached us transformed into myth. A tall order, perhaps impossible. And yet, humans have always sensed that the ground beneath us holds more than we can see. Myths may be our first archaeology, a way of reaching into the past without tools, guided only by imagination. Consider, too, how myths often speak in imagery that mirrors geology. The world swallowed by fire recalls volcanic catastrophe. A flood destroying humanity mirrors rising seas and torrential rains. Winds that strip the world bare echo the scouring of ice ages. Again and again, stories of destruction parallel the forces we know have shaped Earth's surface. Were these parallels coincidence, metaphor, or memory? We cannot know, but the resonance remains. And then there is the question of why humanity clings so tightly to these stories. Why do so many cultures imagine worlds before our own? Perhaps it is humility, an ancient recognition that we are not the center of time. Perhaps it is fear, a quiet awareness that what we build can vanish. Or perhaps on some level, it is intuition that the earth is old, older than we can fathom, and that civilizations are fragile sparks in its endless dark. So as you listen, let yourself drift into the space between myth and geology. Picture the yugas turning, the suns rising and falling, the ages of man giving way one to the next. Picture civilizations erased not just by conquest or decline, but by time itself. And ask softly, could myths be the faintest echoes of worlds before ours? If myths of earlier worlds speak of cycles, then myths of fallen civilizations speak of endings. They are stories of fire and flood, of cosmic battles and sudden loss. They remind us that what rises can also fall, and that beneath the ground we walk upon may lie not only the bones of ancient animals, but the memory of whole worlds that once were. Across cultures, flood myths are among the most enduring. The Epic of Gilgamesh, one of humanity's oldest written stories, tells of waters that rose to swallow the world, sparing only a chosen few. The Hebrew Bible carries the tale of Noah and his ark. In Hindu tradition, Manu is warned of a great deluge by a fish and survives to renew humanity. The Mesoamerican stories speak of floods that ended earlier suns, washing away civilizations before ours. These are not isolated tales, but a chorus. They suggest that across continents, people sensed or remembered that the world itself can drown. Some floods are historical, drawn from real rises in sea level or sudden storms. Others may be echoes of deeper catastrophes, disasters that reshaped the earth in ways too immense to forget. Fire, too, plays its role. In Greek myth, Phaethon, son of Helios, loses control of the sun's chariot, scorching the earth before being struck down. Norse stories foretell Ragnarok, when fire giants march and the world is engulfed in flame. Hindu cosmology speaks of cycles ending in fire before renewal begins again. And in geological time, fire has indeed ended worlds. Massive eruptions, like those of the Siberian traps, filled the skies with ash and gases, suffocating life. To ancient storytellers, such visions may have seemed divine, cosmic punishment, or celestial war. But beneath the symbolism lies a truth. Fire has always been a force of erasure, as much in myth as in stone. Then there are the cosmic battles. The Greeks told of the Titanomachy, a war between gods that remade the order of the world. In Mesopotamian myth, Marduk slays the primordial chaos dragon Tiamat and forms the heavens and earth from her divided body. In Norse sagas, Ragnarok again brings not only fire but stars falling from the sky, a cosmic reset. These battles are more than stories of gods. They are metaphors for upheaval, for worlds destroyed and remade. And they remind us that to the human imagination, catastrophe often appears not as a natural event, but as a cosmic conflict, the shattering of one order to make way for another. Among the most famous of all lost world legends is Atlantis. Plato described it as a powerful island civilization, advanced and proud, which fell out of favor with the gods and was swallowed by the sea in a single day and night of misfortune. To many, Atlantis is pure allegory, a story about hubris and decline, but its grip on the imagination has been immense. Some see it as memory of real ancient cultures, perhaps the Minoans of Crete, devastated by volcanic eruption. Others wonder if it could be a distorted echo of something far older, passed down in fragments, a whisper of civilizations erased not by human frailty, but by geological time itself. Atlantis is not alone. The Doggerland legends of Europe speak of a land once stretching across the North Sea, drowned as the Ice Age ended. In the Pacific, myths tell of islands that sank beneath the waves. In the Andes, stories linger of cities lost to earthquakes and floods. These tales do not need to be literal to be meaningful. They remind us that humanity has always sensed how fragile land, culture, and memory can be. Speculation asks us to take one step further. What if, buried beneath these myths, there lies not only cultural memory of recent catastrophes but echoes of something unimaginably ancient? Could it be that in the deep past, long before humans, a civilization rose and fell, leaving no stone structures for us to find, only a ripple in the collective imagination of life itself? It is a bold thought, perhaps too bold, and yet myths, by their nature, are bold. They reach for truths beyond the measurable, holding on to possibilities even when evidence is thin. Think of it this way. Geology speaks in stone, but myth speaks in story. Both are incomplete, both partial records. If a civilization had once flourished before the dinosaurs, its stone traces might be erased. But its story, however faint, could linger in unexpected places, encoded not in artifacts, but in the archetypes of destruction and renewal that humanity has carried since the first fireside tales. Floods, fires, cosmic battles, lost islands, they are more than entertainment. They are humanity's attempt to grapple with memory and loss on a planetary scale. They may be metaphors, they may be echoes, they may be nothing more than coincidence. But in their persistence, in their universality, they suggest that deep down we have always suspected the truth, that the earth is old, that civilizations are fragile, and that ours may not be the first to rise, nor the last to fall. About 252 million years ago, the earth experienced an ending so absolute that scientists call it simply the Great Dying. It was not one catastrophe, but many, unfolding in waves that reshaped every corner of the planet. Oceans stagnated, forests collapsed. The air itself became poisonous. By the time it was over, more than 90% of marine species were gone. On land, nearly 3 out of 4 vertebrate families had vanished. It was the single most devastating extinction in Earth's history, a reset so thorough that life needed tens of millions of years to recover. To imagine the scale of this event, think first of abundance. Before the collapse, the Permian world was rich with diversity. Synapsids roamed the forests, some small and quick, others large and formidable. Amphibians filled rivers and swamps. Reefs in the seas teemed with life, from brachiopods to ammonites. The world was full of sound and movement. Then, almost suddenly, in geological terms, silence spread. The trigger, scientists believe, was a series of massive volcanic eruptions in what is now Siberia, the Siberian Traps. For nearly 1 million years, lava poured from the earth in unimaginable volumes, blanketing an area larger than modern Europe. Along with the lava came greenhouse gases, carbon dioxide and methane, released in quantities so vast they transformed the atmosphere. Oceans warmed. Currents faltered. Deoxygenated waters spread across the seafloor, suffocating marine life. On land, rising temperatures and toxic air drove ecosystems to collapse. Forests withered. Rivers ran barren. The world became, for a time, almost uninhabitable. Now pause and consider this moment from the perspective of possibility. If there had been a civilization in the late Permian, whether synapsid, cephalopod, or something stranger, this would have been its end. Not a decline stretched over centuries, but a relentless cascade of disasters, each stripping away what had been built. No city, no culture, no memory could survive oceans turning anoxic or skies filling with lethal gases. It would not be conquest or decay that destroyed them, but the earth itself, rewriting its surface in fire. And if that happened, what would remain? Nothing we would recognize. No ruins, no monuments, no tools. The traces would be erased as surely as the trilobites were. Perhaps a chemical anomaly in a sediment layer. Perhaps an unexplained carbon excursion. But even those would blend with the chaos of volcanism, indistinguishable from nature's hand. Civilization would be swallowed whole, remembered only as silence in the fossil record. It is haunting to realize that this extinction was not merely destructive, it was thorough. Other extinctions, like the one that ended the dinosaurs, left ecological niches for survivors to flourish. The Permian-Triassic reset nearly wiped the slate clean. It forced life to begin again from the edges, from small, resilient creatures that could withstand extremes. From that reset, new lineages would rise among them, the ancestors of the dinosaurs. Speculation lingers here, and it is worth entertaining. What if a civilization had risen in the late Permian? What if its members told stories, shaped their environment, even altered the chemistry of the world in ways we cannot yet recognize? Their disappearance in the Great Dying would explain why no trace remains. They would not merely have been forgotten, they would have been obliterated. When you think of extinction in this way, it feels less like an ending and more like an act of erasure. The Earth does not simply destroy, it rewrites. Whole ages vanish, their richness preserved only in fragments, their mysteries folded into stone. The Permian-Triassic extinction is the most dramatic reminder of this. It was not just the end of species, it was the clearing of the canvas, the sweeping away of everything that might have come before. And so, if there was ever a civilization before the dinosaurs, this would have been the perfect eraser. A cataclysm so immense, so unforgiving, that nothing would remain but hints buried in rock. To imagine this is to accept how fragile permanence truly is. Civilizations, even ours, are sparks against the backdrop of deep time. Bright for a moment, then gone. As the Permian ended and the Triassic began, the world was quiet, scarred, and ready for something new. The survivors, few, small, and resilient, would inherit the Earth. And from their persistence, life would rise again, filling the world with forms unlike anything that had come before. The Great Dying at the end of the Permian is often called Earth's ultimate eraser, but it was not the first time the planet reset its canvas. Long before the age of dinosaurs, other extinctions swept across the world, reshaping life in ways both devastating and strangely creative. Each was a test, an interruption, and perhaps if intelligence had ever begun to stir a silencing, the first of these great catastrophes came at the end of the Ordovician, around 443 million years ago. At that time, the Earth was a water world brimming with marine life. Trilobites, brachiopods, and early fish thrived in seas that covered much of the land. Then the climate shifted dramatically. Glaciation spread, sea levels fell, and habitats collapsed. Nearly 85% of species vanished in a geological instant. To us, it is a story written in stone, fossils disappearing from one layer to the next. But if intelligence had flickered in those ancient oceans, perhaps among cephalopods or other early experimenters, it would have drowned in the tide of ice and change. Civilization, if it existed, might have been erased not by conquest, not by decline, but by the turning of the planet's own rhythms. The Devonian, too, brought its reckoning. Sometimes called the Age of Fishes, it was a period of extraordinary innovation. Plants spread across land, forming the first forests. Rivers reshaped landscapes. Insects took to the skies. Amphibians clambered onto shores, their footprints the first signatures of life conquering land. It was a time of expansion, of possibility. Yet the Devonian ended in a long series of extinctions, lasting nearly 20 million years, during which 3/4 of species were lost. Coral reefs collapsed. Whole families of fish disappeared. The causes remain debated: climate shifts, volcanic activity, asteroid impacts, or perhaps the very success of forests, which drew carbon from the air and altered the climate. Whatever the cause, the result was clear: the world reset again, and whatever experiments life had begun were silenced. Speculation draws us further. Imagine that in those lush Devonian swamps, something more than amphibians walked. Imagine that in the shadows of the first forests, a lineage began to wander, to build, to shape. Their rise might have lasted thousands of generations, long enough for stories to be told, for patterns of culture to emerge. And then, as sea levels changed and climates swung, their world would have unraveled. In stone, we see only the vanishing of species, but beneath that silence could lie the disappearance of something far stranger, a civilization erased before it had a chance to leave more than whispers. These earlier extinctions remind us of a pattern. The Earth does not move forward in a straight line. It lurches, stumbles, resets. Life surges in abundance, only to be cut down, only to rise again in new forms. Each cycle is both destruction and opportunity. Each extinction clears the board, and each recovery writes a new chapter. It is a rhythm older than the dinosaurs, older than mammals, older than humanity. A rhythm that makes the rise of civilization feel less like destiny and more like chance. If civilizations did exist before the dinosaurs, the Ordovician and Devonian would have been perfect places for them to vanish. The oceans of the Ordovician could have hidden intelligent lineages of cephalopods, their culture dissolved in floods and ice. The forests of the Devonian could have hosted amphibian societies, swept away by climate shifts and extinctions that spanned millions of years. No ruins would remain, no fossils would tell their story, only the faintest traces might linger in chemistry, mistaken for natural change. And so, these extinctions are not only chapters of loss, they are reminders that the Earth has been an incubator, a laboratory for countless experiments in life. Each time the slate is cleared, new possibilities arise. Each time, life tries again, with new forms, new strategies, new adaptations. Intelligence, if it is not unique to us, may have been one of those experiments. Perhaps it flickered and failed in oceans long gone. Perhaps it rose and fell in forests turned to stone. As you drift with this thought, notice how it softens the edges of certainty. The fossil record is not a diary. It is a patchwork, a scattering of survivors. Between those fragments lie vast silences, stretches of time in which anything might have happened. We fill those silences with science, with story, with myth, and sometimes with speculation. The Ordovician, the Devonian, the Permian. Each extinction was both an ending and a beginning. Each could have been the final chapter of a civilization now forgotten, and each reminds us that the Earth has never been still. It has always been restless, always cycling, always ready to sweep away and begin again. When we talk about intelligence, we often treat it as though it were a single miracle, a rare spark that happened once, in us, and perhaps nowhere else. But Earth's history whispers something different. Over and over, across millions of years, different lineages have stumbled toward awareness, building larger brains, complex behaviors, and glimpses of problem-solving that seem to anticipate civilization. Intelligence is not a solitary flame. It is a fire that nature has tried to kindle many times. Consider the cephalopods once more. Their ancestors date back to the Ordovician, more than 450 million years ago. Without bones, without long lives, they still developed nervous systems so advanced that modern octopuses can solve puzzles, use tools, and escape from aquariums designed to contain them. Their brains evolved independently from ours, following a completely different design. Yet the outcome feels familiar: curiosity, adaptability, and problem-solving. A reminder that intelligence is not limited to one path. Birds, too, show us another route. From small dinosaurs with feathers, evolution shaped not just flight but remarkable cognition. Crows and ravens today demonstrate tool use, memory, even cultural transmission of knowledge. They can plan, deceive, and solve puzzles as complex as those faced by primates. Parrots communicate with stunning precision, and all of this arose separately from mammals, an independent flowering of awareness. Then there are the mammals themselves. Dolphins and whales, with their vast brains and intricate social structures, sing across oceans, navigate with echolocation, and display signs of culture. Elephants remember waterholes across decades, grieve their dead, and shape their landscapes with deliberate action. Primates, of course, gave rise to us, but even among them, chimpanzees craft tools, bonobos cooperate with empathy, and orangutans teach traditions from one generation to the next. What all of these examples suggest is that intelligence is not a freak accident. It is a pattern, a strategy that evolution has discovered more than once, in more than one form, across more than one lineage. It is convergent evolution, the independent arrival at similar solutions because the challenges of life reward them. Eyes evolved multiple times, wings evolved multiple times, and so, too, intelligence. Now, place this understanding into deep time. If intelligence can emerge again and again within just the last 100 million years among birds, mammals, and cephalopods, what might it have done in the hundreds of millions of years before? The Paleozoic was full of candidates, trilobites with their complex eyes, synapsids with their expanding brains, amphibians conquering land, cephalopods already experimenting with cunning. Each of these lineages had millions upon millions of years to explore their possibilities. Each could have stumbled further along the path of cognition. Speculation invites us to imagine civilizations as temporary sparks, flaring up in different forms at different times. Not one continuous story, but many scattered across eras, erased by extinctions, hidden by geology. Perhaps intelligence is less like a crown at the end of evolution's march and more like a recurring pattern, a melody the earth plays again and again in different keys. This perspective shifts our sense of uniqueness. If intelligence arises repeatedly, then civilization is not destiny but possibility. We are one attempt among many, perhaps not even the first. Other sparks may have flared in swamps, in reefs, in forests long before us. They may have lasted for centuries, millennia, or millions of years. They may have reached for culture, for story, even for technology, only to be extinguished by flood, fire, or time. It also raises a deeper question. Why does intelligence keep emerging? Perhaps because awareness offers survival advantages, the ability to adapt to changing environments, to manipulate surroundings, to cooperate in complex groups, or perhaps because the universe, through evolution, seems drawn toward complexity, toward minds that can reflect upon themselves. Whatever the reason, the recurrence of intelligence suggests that it is not rare. It is fragile, yes. Temporary, yes, but not rare. As you drift with this thought, consider Earth not as the stage for one story of intelligence, but as a laboratory of countless experiments. Some succeed briefly, some fail. A few persist long enough to leave a mark. Most are lost, but the pattern is clear. The Earth keeps trying. And that leads us to an unsettling implication. If intelligence arises again and again, then civilizations may be less like singular miracles and more like temporary sparks, scattered across deep time, rising and falling without memory of one another. We may be the latest, not the first, in a chain of forgotten worlds. When we look at intelligence in the context of deep time, it begins to feel less like a crown and more like a flicker. Civilizations, if they appear at all, are brief sparks in the darkness, fragile, impermanent, easily extinguished. The Earth has seen hundreds of millions of years pass between us and the first forests, and in that span entire lineages have risen and vanished without leaving a trace strong enough for us to read. Why would civilizations be any different? Natural disasters are one answer. An asteroid strike can end an age in a single day. Volcanic eruptions can choke skies and poison oceans for millennia. Climate shifts, driven by forces far beyond the control of any species, can collapse ecosystems that once seemed eternal. If intelligence had bloomed before us, it would have faced the same perils. No matter how advanced, no civilization can breathe air filled with sulfur or drink oceans stripped of oxygen. Against the scale of Earth's upheavals, even the most ingenious minds would be as vulnerable as trilobites in the tide. Resource depletion is another. Civilizations consume. They draw from forests, rivers, soils, and minerals. They rely on balance, and when that balance is lost, decline follows. We see it in human history. fertile lands turning to deserts, fisheries collapsing, forests cut to stumps. A pre-dinosaur civilization might have faced the same trap. Perhaps they grew too quickly, relied too heavily on fragile ecosystems, and when those systems faltered, their societies unraveled. In the silence of stone, we would see only the disappearance of species, not the collapse of culture. And then there is the possibility of self-destruction. Intelligence carries not only creativity but also risk. With awareness comes the ability to reshape the world, to build, to expand, but also to overreach. Our own species lives in the shadow of this possibility. Nuclear weapons, climate change, and unsustainable industries remind us daily that civilization is both powerful and precarious. If we are capable of building the means of our own undoing, why not those who came before? Perhaps in some forgotten era, intelligence rose high enough to alter its world, only to fall by its own hand, erased not by volcanoes or asteroids but by choices. This is what it means to see civilizations as sparks. They flare brightly for a time, altering the dark around them, then fade. The record of their light does not linger. The earth resets. Life begins again. Perhaps intelligence emerges once more, unaware of those who came before, believing itself the first. When viewed this way, humanity feels both extraordinary and fragile. Extraordinary, because here we are, a species that has leapt from caves to satellites, from fire to nuclear fusion, from whispers to digital networks. Fragile, because we know how easily it could end. A single catastrophe, a slow exhaustion of resources, or our own missteps could snuff out the spark. In 100 million years, what would remain of us? A thin band of carbon, a scattering of isotopes, anomalies in the rock, nothing more. It is humbling, and perhaps sobering, to recognize that we may be just one in a sequence of forgotten lights. Each civilization, if there were others, thought itself unique. Each believed it would endure. Each vanished, leaving the earth unchanged in its long rhythm. We may be no different. And yet, there is also beauty in this view. To see ourselves as a spark is to recognize the preciousness of the moment. Sparks are fleeting, but while they shine, they illuminate. Our stories, our art, our science, our wonder, they are real. Even if time erases them, they matter in the present, and perhaps that is enough. So as we think of civilizations past and civilizations possible, let us remember, permanence is an illusion. Intelligence is fragile. Civilizations are temporary, and humanity, for all its ambition, may be only the latest flame in a long sequence of forgotten worlds. If a civilization had truly risen before the dinosaurs, then been swept away by extinction and time, what could possibly remain for us to find? Not their cities, not their tools, not even their bones. The eraser of geology is too thorough. And yet, there may still be faint signatures, clues so subtle they blur into the background noise of the Earth itself. Scientists today call these technosignatures when they search for them beyond our planet, hints that another world might have hosted intelligence. But the same idea can be turned inward. What would Earth's technosignatures look like? Not now, but hundreds of millions of years from now. What traces of humanity would survive if we vanished tonight? And could something similar lie hidden in far older rocks, whispers of a civilization long before us? One possibility lies in isotopes, unusual ratios of atoms left behind by industrial activity. When we burn fossil fuels, for instance, we change the balance of carbon isotopes in the atmosphere. That shift is measurable, a fingerprint in chemistry. If another civilization had burned carbon-based fuels millions of years ago, it might have left behind similar shifts, preserved in sediments. Today, geologists study abrupt carbon spikes in the record, often attributing them to volcanic activity or methane release. But could one or two be something more? Could a civilization's fires, long forgotten, echo in the rocks as nothing more than a chemical anomaly. Another clue might be metals. Civilization consumes and refines elements in ways that nature rarely does. Concentrations of copper, iron, aluminum, or rare earth elements in unexpected layers could suggest mining and industry. Our own smelting and waste will leave signatures detectable far into the future. If we found ancient strata with unusual metal patterns, could we distinguish them from volcanic deposits or asteroid impacts? The line between natural and artificial is fine, but perhaps somewhere in the record, it has already been crossed. Then there is the question of synthetic compounds. Plastics, though new to us, are examples of materials that nature cannot produce on its own. Over time, they break down, but fragments embed in sediments, becoming part of the geological record. Millions of years from now, plastiglomerates, fused rock and plastic, will remain as a distinct marker of our presence. If another civilization had once created its own synthetic substances, would we even recognize the residue? Or would we mistake it for an unusual mineral, never realizing it was once crafted by intelligent hands? Even fossils themselves could hold anomalies. Imagine bones or shells altered by technology, infused with metals, shaped by processes unnatural for their time. If such fossils exist, they might be dismissed as curiosities, filed away without deeper study. The vastness of the fossil record makes it easy for singular oddities to vanish into obscurity. Yet perhaps some unusual specimens, waiting in museum drawers, carry traces of something more than biology. This is why some researchers, inspired by the Silurian hypothesis, are beginning to ask sharper questions. They are studying sediments for signs of abrupt changes, chemical shifts, or isotopic fingerprints that might indicate more than natural disaster. They do not expect to find a definitive answer, but the very act of asking broadens our imagination. It reminds us that Earth may carry secrets not in monuments, but in minerals. Picture a team of geologists drilling into ancient rock, pulling up a core sample streaked with dark bands. They measure carbon ratios and find something unusual, something abrupt. They debate causes: volcano, asteroid, methane release. Yet one possibility lingers in the silence. Could this be civilization? Not ours, but one long gone, erased until only chemistry remained. The search for ancient techno-signatures is not only about evidence, it is also about humility. It acknowledges that our own civilization, if measured by geology, would vanish almost without a trace. Our skyscrapers would crumble. Our satellites would fall. But our carbon spikes, our metals, our synthetic compounds, those would endure, faint but real. And if that is true for us, it could also be true for others. So what remains if they existed? Not stories we can read, not ruins we can touch. Only hints, anomalies, signatures hidden in the fabric of stone. To recognize them, we must be willing to look differently, to see geology not only as the record of nature, but as the possible echo of forgotten worlds. When the silence of stone feels too complete, our eyes turn to the outliers, the oddities, the unexplained fragments that seem to sit uneasily within the geological record. These are sometimes called OO parts, out-of-place artifacts. Objects or patterns that appear, at least at first glance, to defy the timeline we believe we know. Stories of such anomalies circulate in whispers and in headlines. A hammer embedded in ancient stone, metal spheres found in deep rock seams, imprints that look like footprints far older than humanity itself. Each of these, when examined closely, often finds a natural explanation: mineral formations mistaken for tools, erosion shaping rock into familiar forms, misdated layers. And yet, their very existence captures the imagination. They remind us of how vast the unknown is, and how easy it is to project civilization into the shadows of geology. Some anomalies resist easy dismissal. The so-called Klerksdorp spheres of South Africa, metallic objects found in Precambrian rock, are often cited as mysterious. Most scientists see them as natural concretions, mineral structures formed by slow processes of chemistry. But their symmetry, their grooves, invite speculation. Could they be natural? Almost certainly. But could they be something else? The ambiguity lingers. In coal mines, too, reports have surfaced of strange finds, imprints that resemble chains, metallic fragments embedded within seams. Most are dismissed as artifacts of mining, contamination from equipment. And yet the imagery persists. The thought that buried within the remains of ancient forests, compressed into coal over hundreds of millions of years, there might be something left behind, not by nature but by hands we cannot imagine. The search for anomalies is not about proof, it is about possibility. Each unusual stone, each curious layer, becomes a canvas for wonder. If civilizations had existed before the dinosaurs, their traces would not be clear monuments. They would be these very kinds of anomalies, singular, confusing, open to interpretation. Most would be explained away. Some would remain as mysteries, filed into the category of unresolved. Scientists are cautious with good reason. The Earth is a master of mimicry. Volcanoes produce glass. Lightning fuses sand into tubes. Pressure shapes crystals into perfect geometry. Nature creates forms that look designed, even when they are not. To separate the artificial from the natural requires evidence so strong it cannot be ignored. And so far, no anomaly has crossed that threshold. But absence of proof is not proof of absence. The geological record is vast, and we have studied only fragments of it. Most of Earth's history lies buried, inaccessible. If a civilization left traces hundreds of millions of years ago, we may never stumble upon them. Or we may already have, dismissing them as curiosities without realizing what they were. Speculation invites us to linger here, in the ambiguity. Perhaps the Klerksdorp spheres are only minerals. Perhaps the reported hammers and chains in coal seams are mistakes. But perhaps, just perhaps, they are faint reminders of worlds before ours, civilizations erased so thoroughly that all that remains are anomalies too strange to categorize, too subtle to prove. If that were true, then the search for anomalies is more than curiosity. It is archaeology at the edge of imagination. It is the willingness to hold open the possibility that the Earth remembers more than we can read. And so, when you hear of an out-of-place artifact, resist the urge to dismiss it outright or to accept it unquestioningly. Instead, let it sit in your mind as a question mark, a reminder that deep time is vast, that civilizations may be temporary, and that some answers may always remain hidden. If civilizations can rise and vanish without leaving memory, what does that say about the story of life on Earth? It suggests that history may not be a single line, but a tapestry woven and unwoven many times. Civilizations might be sparks that flare in the dark, only to be erased so completely that even the memory of their light is lost. And if that is true, then our own place in time is not as singular as we like to believe. We may be unique in this moment, but not unique in eternity. To think of forgotten worlds is to confront the fragility of intelligence itself. We often imagine that once intelligence arises, it will inevitably expand, endure, and grow. Yet deep time suggests otherwise. Intelligence may not be a permanent achievement, but a delicate balance, easily broken by catastrophe, by scarcity, by the very weight of its own ambition. If civilizations bloomed before us, their disappearance is proof that intelligence is not a guarantee of survival. It is a fragile experiment, one that nature may run again and again without ever securing permanence. Are we then extraordinary or simply fortunate? Perhaps we are extraordinary in our awareness, our ability to look backward and forward across time. But perhaps we are also simply lucky the beneficiaries of a stable climate, of continents that drifted into favorable positions, of extinctions that cleared the stage before us. In this view, our civilization is less a pinnacle and more a chance occurrence, one branch of life that happened to find itself in a rare moment of opportunity. And if there were others before us, then what does it mean that they are gone? It means that intelligence alone is not enough. Awareness, creativity, and even technology may not guarantee endurance. The Earth, with its restless cycles, does not promise permanence to anyone. Civilizations are fragile, even when they seem powerful. This thought carries both humility and comfort. Humility, because it reminds us that we are not as secure as we think. Comfort, because it suggests that we are part of a greater pattern, that we belong to a lineage of attempts stretching across deep time. If civilizations before us lived and vanished, then we are not alone in our fragility. We are part of the rhythm of Earth itself. Philosophically, the idea of forgotten worlds reshapes how we think of ourselves. We like to imagine we are the first, the only, the culmination of evolution. But what if we are just the latest? What if intelligence is a recurring theme, one that emerges and vanishes like the tide? Then our stories, our cities, even our ambitions to reach the stars are not unprecedented, but echoes of a larger cycle. And yet, there is a deeper question. If civilizations rise and fall without memory, what is the meaning of their existence? If no trace remains, if no one remembers, were they wasted sparks? Or is the value of a civilization not in its permanence, but in its moment? Perhaps the meaning lies in the light itself, however brief, not in how long it lingers. When you consider this, humanity's place feels both smaller and more precious. Smaller because we are not the inevitable center of history. Precious because our moment is fleeting, and that makes it matter all the more. To live, to create, to wonder, even if erased in time, is still to shine. So the philosophy of forgotten worlds is not only about what might have been, it is also about how we live now. If we are just the latest in a hidden chain, then we carry a responsibility not only to ourselves but to the pattern itself. To tend our spark, to make it meaningful, even if the earth will one day sweep it away. There is a quiet fear woven deep into the human story, the fear that we are not the first. Across cultures and centuries, we have told ourselves that we stand at the pinnacle of creation, the culmination of evolution, the latest and greatest expression of life. To imagine otherwise unsettles us. It means that our place in history is not singular but provisional. It means that the crown we place upon our own heads is less a destiny than a coincidence. This fear has many roots. One is psychological. We long for meaning, for permanence, for the sense that our struggles and triumphs matter in some larger story. To believe we are the first intelligent civilization gives us that assurance. It makes our existence feel inevitable, even sacred. But to admit the possibility of forgotten civilizations undermines that comfort. It places us within a chain, not at its end. It reminds us that if others rose and fell before us, then we, too, will vanish in turn. Another root is cultural. Our sciences, our philosophies, our religions often frame humanity as exceptional. We are the image bearers, the rational animals, the species that looks to the stars. We measure progress by how far we have come from what we call primitive beginnings. The idea that other civilizations may have risen in ages long before us complicates that story. It suggests that intelligence is not uniquely ours, and that progress does not necessarily endure. For many, this thought is uncomfortable, even threatening. And yet, why should we resist it? Humility in the face of deep time is not diminishment. It is expansion. It places us within a cosmos more complex, more layered than our narrow histories allow. To imagine forgotten civilizations is not to deny our worth, but to situate it within a grander rhythm, a rhythm of rising and falling, of sparks flaring and fading across millions of years. Think of the psychological drive to see ourselves as the pinnacle. It is natural, but it is also fragile. If we are the first, then everything depends on us. Our survival, our choices, our stewardship of Earth become the only experiment intelligence has ever run here. But if we are not the first, if we are one among many attempts, then our survival is no less important, but it is placed in context. We are a chapter, not the whole book. Speculation carries us further still. What would it mean for our culture, our science, our sense of self, if we embraced the possibility of forgotten civilizations? Perhaps it would shift our values. Perhaps we would see intelligence not as an achievement to be proud of, but as a fragile gift to be tended carefully. Perhaps we would approach the Earth not as a resource to be consumed, but as a partner that has hosted countless experiments in life, each fragile, each brief. To let go of the fear of not being first is to accept humility in the face of deep time. It is to admit that permanence is an illusion, that intelligence is not guaranteed, that civilizations can vanish without memory. But it is also to see beauty in that truth, for if we are one spark among many, then we are part of something vast. Our brief moment of light contributes to a pattern older than mountains, older than oceans, older even than the dinosaurs. So let us not cling too tightly to the idea of being the first. Let us instead embrace the possibility of being part of a hidden chain, one that stretches backward into forgotten worlds and forward into futures we cannot yet imagine. For in the end, what matters is not whether we are first or last, but how we tend the light while it is ours. When we lift our eyes beyond Earth, we see reminders that our planet is not alone in its experiments. Mars, dry and barren now, once carried rivers across its surface. Its canyons were carved by flowing water, its basins once filled with lakes. Billions of years ago, it may have worn a blue sky and a warmer climate, conditions familiar to us. Venus, too, may once have been temperate, its surface shaded by oceans, its atmosphere thin and mild. Today it is a furnace, cloaked in clouds of acid, its surface hot enough to melt lead. Both planets stand as silent witnesses to possibility worlds that might once have been habitable, but which turned, in time, toward desolation. These planetary neighbors offer us lessons in fragility. They remind us that Earth is not exceptional in its capacity to host lifelike conditions. Oceans, atmospheres, stable climates. These are not unique gifts. They are common outcomes, at least in the early histories of rocky worlds. But they are not guaranteed to last. Mars lost its magnetic field, and with it, its atmosphere. Venus spiraled into a runaway greenhouse, a mirror of what happens when balance tips too far. If civilizations had ever arisen there, their traces would now be buried, erased, or melted into oblivion. Speculation invites us to take this further. What if Mars once carried not only rivers but life, perhaps even intelligence? What if Venus nurtured ecosystems beneath its early seas, rising toward awareness before collapse swept them away? If so, then Earth is not the lone experiment. It is one of many, part of a solar system that tested the boundaries of habitability on multiple stages. From this perspective, civilizations may not be rare. They may emerge whenever conditions allow, brief sparks on planets across the cosmos. But the lesson of Mars and Venus is that sparks do not endure. Worlds shift, atmospheres vanish, temperatures swing to extremes. Even intelligence cannot resist planetary change. And so, the cosmic perspective begins to settle in. If intelligence is fragile, then the universe may be full of civilizations that rise and fall without ever knowing one another. Stars may host planets where life begins, reaches for awareness, builds briefly, and then vanishes, leaving only subtle chemical scars in the rock. From a distance, we would never see them. From their perspective, they would never know us. This humbles us. It places humanity not at the center, but among countless possibilities. Earth is one experiment among many, and our civilization one outcome among perhaps thousands, millions, or more. We are not alone in the cosmos, but we may be alone in this moment, our spark separated from others by gulfs of time. And yet, there is comfort in this, too. For if civilizations are common but fragile, then we are part of a cosmic pattern, a rhythm that stretches beyond Earth. Our light may not last, but it is shared. Our fragility is universal. And in knowing that, we can see ourselves more clearly, not as rulers of the cosmos, but as participants in its great experiment. So let Mars and Venus be reminders, not of despair, but of perspective. They tell us that worlds change, that oceans dry, that climates collapse. They tell us that civilizations, if they arise, must live within the delicate balance of their planets. And they remind us that even if we are not the first, even if we are not the last, our moment of awareness is precious. If Mars and Venus remind us of fragility, Earth reminds us of persistence. For 4.5 billion years, this planet has been restless, creative, destructive, and renewing. Oceans have come and gone. Continents have broken and rejoined. Species have risen and fallen. And through it all, the Earth has carried out an unending series of experiments, testing what life can become. In this sense, Earth is not just a home, it is a laboratory, a place where intelligence may not be a singular event, but a recurring trial, rising and falling across eras. When one branch collapses, another may climb. When extinction sweeps the board clean, life writes again in new forms. The record of stone is not the record of failure, but of resilience, of attempts uncounted. Consider the Cambrian seas, where eyes and shells first exploded into diversity. That was one experiment. The Devonian forests, where plants reached upward and amphibians walked onto land, another experiment. The Permian, with its synapsids and complex ecosystems, yet another. Each ended in collapse, but each also prepared the ground for something new. If intelligence is part of evolution's rhythm, then it too may have emerged in cycles. Brief civilizations flaring into existence only to be erased when the Earth shifted beneath them. From this perspective, humanity is not the pinnacle of a linear path, but one chapter in a book still being written. We are the current experiment, alive in a moment of balance, building our stories upon the ruins of forgotten worlds. The Earth may have nurtured civilizations before us, and it may nurture civilizations after us. Each spark is brief, but together they form a larger pattern, the ongoing exploration of what intelligence can be. This way of seeing unsettles, but it also expands. It tells us that our uniqueness lies not in being first, but in being part of something greater. It reminds us that permanence is not the measure of value. A civilization need not endure forever to matter. Its meaning is in the light it brings, the awareness it carries, however briefly, into the universe. Speculation asks us to imagine Earth as a kind of cosmic storyteller. Each age is a new chapter. Each extinction is a turning of the page. Some stories are short, others long. Some are tragedies, others comedies of survival. Ours may be both a tale of brilliance and of fragility, of reaching far and yet risking collapse. But it is not the only tale. It is simply the one being told now. And if we are one chapter among many, then our responsibility is not to cling to being the first or the last. It is to live our chapter well, to tend the balance of our planet, to nurture the fragile gift of intelligence, to create meaning even if time erases the record. For in the laboratory of Earth, permanence has never been the rule. Renewal has. So let us see ourselves not as a final answer, but as part of the experiment. Let us recognize that forgotten civilizations, if they existed, were not failures but participants in the same grand rhythm. And let us remember that after us too, the earth will go on, perhaps preparing the stage for others to rise, others to wonder, others to shine. From the silence left behind by the Permian extinction, a new age slowly began to take shape. Survivors crept forward into the vacant spaces, small and unassuming at first, but carrying within them the seeds of transformation. Out of this long recovery came one of Earth's most enduring and extraordinary experiments, the age of the dinosaurs. For 165 million years they ruled. From the Triassic through the Jurassic and into the Cretaceous, they spread across every continent, filling niches from towering herbivores to swift predators to small feathered flyers. Their dominance was not brief, not fragile, but a reign longer than the entire span of mammals that has followed since. Forests echoed with their footsteps. Skies were crossed by wings that stretched longer than buses. Seas churned with reptilian hunters larger than ships. It was an era of scale, of abundance, of astonishing success. And yet, through all this time, there is no evidence of civilization. No cities in the strata, no tools in the fossil beds, no sudden signatures of industry or technology. The dinosaurs, for all their mastery of the earth, appear to have followed paths of strength, speed, and endurance, rather than the peculiar path of intelligence that we know so well. But here we may ask a gentler, stranger question. Could intelligence have been suppressed by their reign? Evolution is not a ladder but a branching tree. Each branch competes for light, for space, for survival. In an age dominated by giants, perhaps the small, the fragile, the clever had little room to flourish. Mammal-like creatures survived, but they remained in the shadows, nocturnal, tiny, waiting. Birds descended from certain dinosaurs, and some showed remarkable complexity. Yet none reached for civilization. Imagine if things had been different. Suppose a lineage of feathered dinosaurs had pressed further into cognition, shaping tools with claws, creating cultures in forests that are now lost to stone. Or picture small mammals, huddled in burrows, evolving larger brains but kept forever at the margins by reptilian rulers. Could there have been sparks of intelligence, cut short not by catastrophe but by competition, by the weight of a world dominated by giants? Speculation lingers here. Intelligence may not be a guaranteed outcome, even when conditions allow. It may require windows of opportunity, gaps in dominance, openings in ecosystems where new possibilities can take root. The reign of dinosaurs may have been too stable, too successful, leaving little room for other experiments to grow. Civilization, if it tried to rise, may have been stifled before it had a chance. This perspective is humbling, for if intelligence requires not only the right adaptations but also the right timing, then our own existence feels even more improbable. We are not simply the result of evolution's creativity, but of circumstance, of windows opened by extinctions, of opportunities shaped by chance. And yet, even in the age of dinosaurs, there were hints of what might have been. Some species displayed social behavior, nesting in colonies, protecting their young. Others developed complex hunting strategies. The seeds of intelligence were not absent. They were present, scattered, but never brought to full flame. The reign of dinosaurs was a long experiment in dominance, but perhaps one that left little space for civilizations to emerge. When their time ended suddenly, 66 million years ago, with the impact of a wandering asteroid, it was mammals who stepped into the light. The small, the clever, the adaptable, and from them, in time, came us. The question remains, had the dinosaurs continued their reign, would intelligence have ever had another chance? Or would the Earth still be theirs, an empire of strength without the spark of civilization? These are questions without answers, And perhaps that is the point. The age of dinosaurs reminds us that intelligence is not inevitable, even over 165 million years. It is fragile, contingent, dependent not only on biology but on opportunity. And in the silence of that reign, we glimpse how easily the spark of civilization might have been delayed, or extinguished, or never kindled at all. When we speak of the dinosaurs, it is easy to let their enormity dominate our imagination. Their reign lasted for 165 million years, a span so vast it dwarfs the entire history of humanity. Yet even the age of dinosaurs is only a recent chapter in the library of deep time. Before them lies a billion years of life, most of it hidden, most of it silent in our records. Reflect for a moment on that scale. Earth is 4.5 billion years old. Dinosaurs appeared around 230 million years ago, meaning that for over 90% of Earth's history, they did not exist. For nearly 4 billion years, the planet was alive without them. Entire worlds rose and fell before their first step shook the soil. The seas swelled with creatures strange and now forgotten. Forests spread, collapsed, and spread again. Civilizations, if they ever bloomed in that immensity, would be buried beneath aeons of stone. Even the creatures we know from that pre-dinosaur age are fragmentary in our knowledge. Trilobites scuttled across seafloors for nearly 270 million years, longer than dinosaurs would later rule. Cephalopods with coiled shells once dominated the oceans, their lineages stretching into ages when continents were unrecognizable. The first forests shaded amphibians exploring land. Synapsids prowled in ecosystems as complex as anything today. Each of these eras was full, rich, alive with possibility. And yet, when we look back, we see only scattered fossils, fragments of a story too large for us to hold. This is what makes pre-dinosaur Earth so mysterious. We measure time in human generations, in centuries, in millennia. But to think of hundreds of millions of years is to enter a realm where memory dissolves. The rock record is patchy. Whole continents have been recycled by plate tectonics. Mountains have risen and eroded into dust. Oceans have vanished, replaced by others. Against such churn, what hope would there be for a civilization to leave its mark? And so, even the dinosaurs' giants in our imagination appear recent when measured against the true span of Earth. They are not the baseline of deep time, but an interlude near the present. What came before them stretches further than our minds can comfortably grasp. The billion years before their reign is like an ocean into which we have dipped only a toe. It is within that ocean of time that speculation lingers most strongly. If intelligence has emerged multiple times, if civilizations are sparks in the dark, then the pre-dinosaur Earth had more than enough opportunity for such sparks to flicker. They could have risen and fallen not once, but many times, each erased so thoroughly that only silence remains. To us, it looks like absence, but perhaps it is only loss. This perspective changes how we think of history. We often imagine humanity as the latest in a line stretching neatly back through mammals, dinosaurs, amphibians, and fish. But the truth is less tidy. The tree of life is tangled, full of branches cut short, experiments ended, possibilities unrealized. A billion years before the dinosaurs, the Earth was already experimenting with complexity, with ecosystems, with awareness. It was already a stage upon which civilizations might have played and perished. When you stand beneath the night sky and feel the weight of time, remember this: the dinosaurs themselves are latecomers. Even they belong to a recent layer of the story. Beneath them lies a depth we can scarcely fathom, a billion years of forgotten worlds, written not in books, not in memory, but only in stone. If the billion years before the dinosaurs are a vast library of lost chapters, then we, today, are its tentative readers. Humanity has become an archaeologist of deep time, armed not with shovels alone, but with sciences that allow us to peer into the fabric of the Earth itself. Geology, paleontology, isotope analysis. These are our lanterns in the dark, our instruments for sifting silence into story. Geology is our map. By studying layers of stone, we reconstruct the shifting of continents, the rise and fall of oceans, the cycle of mountain and plain. Each stratum is a page, pressed with fossils, minerals, and chemical signatures. Geologists can tell us when deserts spread, when glaciers advanced, when volcanoes blanketed the sky. Yet even this record is incomplete. Erosion erases, plate tectonics recycles. The oldest crust has been swallowed into the mantle, its history forever lost. For the earliest chapters of Earth's story, we hold only fragments, and from them we must imagine the rest. Paleontology is our storyteller. Fossils are the voices that survive, carrying whispers of bodies long dissolved. Trilobites, ammonites, dinosaurs, mammals, each fossil is a moment of preservation, a chance accident that lets us glimpse an entire way of life. But fossils are rare. For every creature we uncover, countless others have vanished without record. Whole ecosystems lived and died without leaving a single trace. Civilizations, if they ever arose before the dinosaurs, would be far less likely to fossilize than shells or bones. Their memory would be fainter still, perhaps invisible to paleontology's tools. Isotope analysis is our chemistry of memory. By measuring the ratios of carbon, oxygen, and other elements in rock, we can reconstruct climates, trace extinctions, and even detect industrial activity in our own age. Future scientists, looking back, will see humanity in a sharp carbon spike, a chemical fingerprint etched into the atmosphere and oceans. Could we find similar fingerprints from long before the dinosaurs? Perhaps, but the signals blur with time. Volcanism, asteroid impacts, methane releases all mimic the patterns we might attribute to industry. To read isotopes is to read ambiguity, where natural and artificial blend into one. These are the tools we wield, and with them we reach astonishing insights. We can say when oceans turned anoxic, when forests collapsed, when the earth warmed or cooled. We can trace mass extinctions with precision, mark them in stone across continents. But even with all this knowledge, there are limits. Beyond a few 100 million years, the record grows faint. The deeper we probe, the less certain we become. We can reconstruct patterns, but not stories. We can measure chemistry, but not culture. We can see extinctions, but not civilizations. And so we stand at the edge of deep time, able to glimpse but not grasp. We can say with confidence that Earth is old, that life is resilient, that extinctions reshape everything. But when we ask whether intelligence has risen before, our tools fall silent. The evidence, if it exists, is hidden beyond reach. This silence is not failure, it is the nature of the task. To be archaeologists of deep time is to work with fragments, to piece together a mosaic that will always be incomplete. Our science is powerful, but the Earth is older still. It has erased more than we will ever recover, and perhaps that is why the question lingers. The limits of science leave space for speculation, for wonder, for the possibility that civilizations rose and fell before the dinosaurs, leaving only whispers in chemistry and myth. To search for them is not to expect certainty, but to explore humility, the recognition that we may never fully know. So, as you think of humanity as archaeologists of deep time, imagine our tools as lanterns in a cave. They cast light, but only so far. Beyond their glow lies darkness, filled with questions we cannot answer. And in that darkness, perhaps, lie the forgotten worlds. If our sciences are lanterns in the dark, then every drill, every core sample, every fossil hunt is an attempt to push that light a little further. We are, in a sense, searching for ghosts, not of individuals, but of entire worlds. The question is not only whether civilizations existed before the dinosaurs, but whether our tools could ever recover their memory if they did. Drilling into the earth gives us some of our deepest glimpses into the past. Core samples pulled from ocean floors contain layers of sediment, each one a chapter in time. Tiny shells of plankton record climates millions of years gone. Bands of ash tell of eruptions that once shook the skies. Within those layers, we sometimes find abrupt changes, chemical spikes, sudden disappearances, curious anomalies. These are the signatures we read carefully, weighing natural explanations against the faint possibility of something more. If a civilization had altered the Earth long ago, perhaps its echo would lie here, disguised as a band of carbon or a trace of unusual metals. Ice cores, though younger, are another form of archive. From Antarctica and Greenland, we extract cylinders of frozen time, bubbles of ancient air trapped within. They reveal past climates, past atmospheres, even traces of volcanic eruptions and wildfires. Ice cannot take us back to the Paleozoic, but it teaches us how memory can be stored in unexpected places. If forgotten civilizations left their mark, perhaps it is not in monuments, but in hidden archives like these records of chemistry. Not of stone. Fossil hunts remain our most vivid connection to deep time. Every quarry, every dig, every slab of shale may hold imprints of life millions of years gone. Sometimes we find exquisite detail, the veins of a leaf, the outline of a feather, the ripple of skin. Other times we find mysteries, forms we cannot easily classify, patterns that defy our categories. Could any of these be misread evidence, artifacts mistaken for nature? It is unlikely, but not impossible. A civilization that shaped its environment subtly, or in ways foreign to us, might leave marks that blend into the fossil record, unrecognized for what they are. Speculation invites us to wonder, maybe the evidence is already here. Maybe it lies in museum drawers, labeled as mineral oddities. Maybe it is buried in cores, dismissed as contamination. Maybe it is in fossils we call enigmatic, because they do not fit neatly into known lineages. The difficulty is not only finding anomalies, but recognizing them. Our minds are trained to see nature, not culture, in the record of stone. What if some of the patterns we attribute to volcanism or climate change are, in fact, echoes of intelligence erased? This is not to say that proof lies waiting, only that possibility lingers. The rocks are full of ghosts, and our tools, however advanced, can only reveal part of their story. Technology may grow sharper. We may one day detect subtler isotopic fingerprints, trace more delicate mineral residues, or model ecosystems with unprecedented precision. But even then, the line between natural and artificial will remain blurred. Civilization, if it rose before the dinosaurs, may be indistinguishable from the Earth itself. And perhaps that is fitting, for if intelligence is part of Earth's rhythm, then its traces would not be foreign to the planet, but woven into it. Civilization would not stand apart from nature. It would dissolve back into it, becoming geology, becoming chemistry, becoming stone. What we search for, then, is not alien to the Earth, but a hidden face of the Earth itself. So when we drill, when we core, when we sift through fossils, we are not only studying the past, we are listening for whispers, searching for ghosts. And though we may never know with certainty, perhaps it is enough to keep asking. Perhaps the act of searching itself is the way we honor the possibility of forgotten worlds. If civilizations truly came before us, if intelligence bloomed in ages long forgotten, then the implications reach far beyond geology. It would mean that humanity is not unique in the story of Earth, but one chapter in a much longer book. Our technologies, our myths, our stories, these might not be unprecedented inventions, but echoes of patterns repeated across time. Imagine what this means for our sense of history. We often speak of the dawn of civilization, as if it were a singular sunrise, beginning with Mesopotamia or Egypt, with the first cities and written words. But what if there were other dawns, long before, rising and fading across deep time? What if the cycle of intelligence and collapse has happened not once, but many times, each leaving no memory but shaping the rhythm of life? Our own dawn, then, is not the first light, but the latest in a series of forgotten mornings. Our technologies may also be less novel than we think. Fire, metallurgy, writing, machines, we see them as hallmarks of our ingenuity. Yet if other civilizations once walked this earth, they may have discovered their own versions, built from their own materials, shaped by their own needs. Perhaps their tools were not stone or metal, but substances now dissolved into sediment. Perhaps their cities were not built of brick but of living organisms, symbiotic architectures now fossilized beyond recognition. Perhaps what we call progress is a pattern, one that life rediscovers again and again, each time in a different form. Even myths might carry faint reflections of these cycles. Floods, fires, cosmic battles, we interpret them as allegory or memory of natural disasters. But what if they also echo something deeper? What if some myths are distorted memories of forgotten ages, passed down not in fact but in archetype, fragments of civilizations erased so completely that only story could survive? If so, then myth and history are not opposites but companions, two ways of remembering across impossible spans of time. This possibility reframes how we see ourselves. Instead of the pinnacle of evolution, we are participants in a recurring experiment. Instead of singular, we are plural, one spark among many. Intelligence, then, is not destiny but rhythm, fragile, impermanent, but persistent across eras. There is also a more sobering implication. If civilizations rose before us and vanished, then our own fate may be less secure than we imagine. The earth may not favor permanence. It may favor cycles, rise, flourish, collapse, renew. In this light, our technologies are not shields against extinction, but expressions of the same pattern. We may build higher, reach farther, dream bigger, but we too may fade, becoming only a chemical trace in the stone. And yet, this view does not strip meaning from our existence. It deepens it. To see ourselves as one chapter among many is to recognize the value of our moment. Our stories matter because they are part of a larger chorus, a rhythm of awareness echoing across time. Our myths matter because they may carry the memory of forgotten ages, weaving us into a tapestry greater than we can see. Our technologies matter because they, too, are expressions of the Earth's experiment, ways of shaping and being shaped. So if civilizations came before us, let us not fear the thought. Let us instead embrace the humility it brings. We are not alone in time. We are part of a chain, fragile, fleeting, beautiful. The cycle of memory and loss may be endless, but within it, each spark of intelligence carries its own light, its own meaning, its own chance to wonder. Imagine, for a moment, that all the ghostly echoes we've been listening for never quite resolve into other voices. Imagine that the long corridors of deep time are empty of earlier storytellers, that the shelves behind us hold no other civilization's books, that the lamp we're holding is the very first light this planet has ever raised to see itself. Not a relay in a chain, but the opening note, not a chorus, but a first, tentative solo carried across a vast and listening silence. To rest inside, that possibility is to feel a particular weight settle over the room, not a dread, but a density, the way midnight air feels before a snowfall. Because if awareness has assembled only now, after 4.5 billion years of ocean and rock, of lightning and microbes, of forests rising and falling and rising again, then something exquisitely narrow has been walked. You can sense the gates we pass through, each one just wide enough for a passerby, a star steady enough to cradle a world without frying it. A distance just so, where water can pool and not boil away. A planetary core that spins and hums, casting a magnetic lantern against charged solar winds. A crust thin enough to fracture, thick enough to raft continents, forever recycling carbon and minerals through seas and sky. There is the gift of a moon of the right size, tugging at our axis to keep the seasons temperate. The comfort of plate tectonics, endlessly stirring nutrients and sculpting habitats. The quiet alchemy of water, solvent of worlds, stitching molecules into something that could grow. Think of the chemistry that learned to copy itself, of cells that swallowed other cells and decided to share the work, of oxygen, first a poison to a planet that didn't yet know what to do with it, later a breath that made muscles and minds possible. Think of ice ages that nearly pinned the world in white, and the slow warming that released it, of the Cambrian's sudden experiments with eyes and armor, of the clumsy, miraculous first footsteps onto land, of forests that engineered the air, of extinctions that unmade what was most sure of itself. Think of dinosaurs, great and long and everywhere, and the small, warm-blooded creatures who learned to bide their time beneath their feet. Think, too, of the pebble from the sky that tipped the table, and of the mammals that poured into the spaces it cleared. Of hands that learned to hold and to strike sparks, of tongues that learned to sing. If we are the first, all of that becomes not simply the preface to our page, but the braid of contingencies that makes this line possible. It is not just unlikely, it verges on the miraculous, a necklace of narrow doors, each one opening because the one before did. And if that's so, then this moment you breathing in a darkened room, the soft machinery of your chest rising and falling, a voice meeting your attention is rarer than anything you can weigh. Not because we are superior to what came before, but because of how staggeringly many ways this could have failed to happen at all. To be first is to be entrusted. It means the planet, after all its experiments with stone and weather, with leaves and gills and feathers and teeth, has at last offered itself the gift of a creature that can notice the gift. The first eyes to look back at the oceans and see them as home and history. The first hands to hold a rock and call it time. The first minds to count the pulses of stars and wonder who else might be counting with them. There is responsibility braided into that realization, the way iron is braided into your blood. The task is not simply to keep going, it is to keep going well. Responsibility sounds heavy, but in the quiet it feels more like attentiveness. It sounds like learning the rhythms of a body you're new to inhabiting and deciding not to push it beyond its breath. The earth has its cycles, carbon in the air, water in the clouds, phosphorus riding the river to the sea and back again. And to be first is to learn how to move inside those cycles without tearing them. The lessons are not theoretical. They land in tangible places, soil that holds or loses its richness depending on what we take and return. Forests that carry rain inward by transpiring it skyward. Oceans that store heat and carbon and life in layers, stratified like books on a shelf. To love the privilege of being first is to apprentice yourself to those systems, to become literate in them, to speak softly in a house that echoes. There is another duty, and it is older than duty, care for company, not only for our own kind, with our crowded cities and patient elders and newborns who arrive as small astonishments, but for the breathing parish that made us possible, the salmon writing their silver script upriver, the lichens translating sunlight into stone speech, the octopus whose thoughts are written in ripples of skin. If we truly are the planet's first self-reflection, then the mirror is a communal one. We are thinking on behalf of a chorus that cannot say "we" except through us. To be the first is to be an advocate, a translator, a keeper of more than human stories. The mind, being what it is, travels beyond the room. It goes to the wide, cold distances and counts probabilities with a childlike faith in numbers, asking whether other lights burn elsewhere. Perhaps they do. Perhaps the galaxy is freckled with brief intelligences we will never meet, each one rising like a moth to the brief candle of its world, flickering and darkening again. But first is a local condition. It belongs to the ground under your feet. If Earth has produced no other thinking species before now, then the cosmic question is tendered into a more intimate key. The silence above becomes less a loneliness than a permission to make a first answer. What does a first answer sound like? Maybe it sounds like restraint, a decision to leave some things unburned, some rivers unshackled, some mountains unbroken. Maybe it sounds like patience, the choice to build on timescales that do not fit into election cycles or quarterly reports, but into rings of trees and migrations and the long return of comets. It might sound like cathedral projects, seed vaults that will outlast us, forests planted by hands that will not live to see them tall, archives written in stone and sapphire and ice, so that whatever follows, if anything follows, can read. It is not hard to imagine future minds, human or otherwise, finding our messages sent forward in shells we designed to endure, and exhaling a glad breath at not being alone in time. And yes, it may also sound like apology. We will err. We already have. To be the first is not to be flawless. It is to be willing to learn. It is to attend to feedback from a world that answers in floodplains and coral bleaching, in the quieting of birds, in years that come too hot and yet somehow are the coolest we will know for a while. The point of responsibility is not purity. It is course correction. It is humility sharpened by data and softened by grace. There is a paradox tucked into this, and it is worth holding as you might, a smooth stone in your palm. If we are the first, we are both the most vulnerable intelligence Earth has ever grown, and the most obligated. We must design for failure even as we plan for continuity. That means redundancy in the simple things, seed, water, knowledge, and elegance in the complex. It means learning from systems that have persisted longer than cities can dream, prairies that carry fertility forward in cycles of fire and regrowth, kelp forests that engineer their own weather, fungal networks murmuring traffic beneath the soil. It means treating prosperity not as the speed of throughput, but as the durability of relationships, between people and places, between present selves and future ones, between the stories we prefer and the truths that keep us alive. If we are the first, then the cradle of our thought, this thin, breathing film around a cooling molten heart, is also the archive that will speak for us when we are gone. We can choose what it says. It could be a line of ashen plastic. It could be the sudden tilt of carbon isotopes that future readers will measure with a scientist's sorrow. Or it could be a gentler inscription, the turning of the spike into a curve that returns toward balance, the unspooling of damage, the meticulous, patient act of restoration written over centuries in slower floods and kinder storms and reefs that remember color. Being first changes the scale of what counts as success. It is no longer only the brilliance of our inventions or the reach of our ships. It is the way an old river still finds its floodplain without drowning a city. The way a harvest leaves more than it takes. The way a child can hear a thrush in a city dawn because we made room for trees. It is not less grand than rockets. It is simply grand in a tone this planet understands. There is an art to staying. Long-lived cultures know it. They move with land and season, not against them. They build where the ground welcomes and abstain where the ground refuses. They make memory portable so that when the coastline moves, the songs do not drown. If we are the first, we need such arts carried forward into the age of satellites and circuits, a marriage of ancient literacy with modern reach. Call it deep-time citizenship. Call it planetary etiquette. Call it the ordinary heroism of living within our means so that means still means something 1,000 years from now. It helps to remember that we are not separate from the intelligence we praise. The mind is not only behind the eyes and inside the skull. It is distributed. in the ways we coordinate, trade, and care, in the networks that route food and ideas, in the agreements we keep when no one is watching, in the laws we revise when the world changes its terms. If we are the first, let the intelligence we practice be one that grows kinder as it grows stronger, a mind that can carry the weight of being primal without becoming proud. There will be temptations to measure worth by the brightness of our wake, to leave signatures not because they are needed, but because we wish to be remembered. Yet deep time gently insists that the only memorial that endures is balance. The most eloquent monument a first civilization can raise is a living planet, passed to its inheritors, whether they are our descendants or not, with the engines of rain and soil and ocean purring as they should. There is a style of glory that looks like restraint. There is a music that sounds like continuity. If you lean close, you can hear the practical suggestions aggregated in the hush. Keep carbon in the ground when we can, and return it when we have learned to keep it safely. Build cities that digest and circulate rather than consume and discard. Rewild corridors so migrations can resume the ancient conversations they held with mountains and coasts. Write libraries into rock and clay and crystal so the long time can read us. Design institutions calibrated not only to weather a human lifetime, but to make decisions that feel responsible to people unborn. When we draw maps of value, include watersheds and pollinators and cloud-making forests, not because we are sentimental, but because we are newly literate in how our home actually works. All of this sounds large, and it is, but it keys back into something small and personal you can feel in your ribs. To be first is to carry gratitude as a daily practice. Gratitude that you wake in a world that holds you up at 1G, that filters starlight through an atmosphere that lets you breathe, that seasons your days with dawn and dusk at a tilt that paints winter and summer onto your calendar. Gratitude that you can step outside and hear, even faintly, the older languages water over stone, wind rehearsing its lessons in leaves, the soft arithmetic of insects in the heat. Gratitude that you get to try, with all of us, to keep this first light burning. It is no guarantee that we will succeed. There are still fossils of failure in the bedrock of our choices, but the gift of being first is the permission to learn quickly, to imagine far, to borrow humility from the immensity behind us and courage from the immensity ahead. We have time's full attention for a moment. What we say with it matters. And so, with the gentleness the hour invites, let a promise settle between us, not a shouted vow, but a quiet intention with long roots. That we will be good ancestors to strangers we will never meet, that we will measure our cleverness by the health of the systems that cradle us, that we will teach our children to ask beautiful questions and to listen for patient answers, that we will treat wonder not as entertainment, but as instruction, that we will make of our firstness something the earth can look back on, in whatever manner the earth remembers, and feel a kind of relief. Outside, night carries the old constellations across the window like lanterns. Somewhere, a tide is turning on rock. It has traveled for longer than any story. The planet hums. We hum with it. If this is the first mind Earth has raised to the mirror, then let it be a steady one, a kind one, a mind that knows the difference between noise and music, and when the time comes for the page to turn, as pages always do, let the next line inherit a living book. The Earth's past is vaster than we can hold in thought. 4.5 billion years of oceans rising and falling, continents colliding and breaking apart, forests blooming and turning to ash. Within that immensity, whole worlds could have come and gone, civilizations born and lost before even the dinosaurs stretched their shadows across the land. And yet the rocks are mostly silent. They keep no diaries, only fragments, only whispers. So we are left with questions. Are we alone in time? The very first voice the earth has carried into self-reflection? Or are we part of an endless cycle, one link in a chain of sparks scattered across deep time, each rising, each vanishing, each leaving behind only the faintest trace. As you drift into rest, imagine ancient oceans glowing under alien skies. Imagine forests filled with creatures whose names we will never know. Imagine civilizations so thoroughly erased that only the stones remember, their stories pressed into silence by the turning of the earth. We may never know the answer, but perhaps that is the gift, to live not with certainty, but with wonder, to dream not only of where we come from, but of the forgotten worlds that may have come before. Good night.